In today's video, we're simplifying the complex world of wood screw sizes, types, and options. Plus, you'll have a chance to download 3 different charts to help you make sense of it all. Just so everybody's starting from the same place, we need to first briefly talk about the anatomy of a traditional wood screw. Starting at the top, we have the screw head, the shank, the threads, and the tip. Now, each one of these can vary, as we'll see later. There are 4 main measurements that can be taken from a wood screw: the head diameter, the shank diameter, the thread diameter, which is also called the major diameter, and then the root diameter, also called the minor diameter. The head size for wood screws is sometimes labeled as a max measurement on screw charts. For example, the number 6 or 3.5 millimeter screw has a max head diameter of 0.279 inches or 7 millimeters. It's most likely labeled as a max size because a lot of wood screws actually have smaller heads than the max size diameter. Next is the shank size. This is the diameter of the smooth part of the screw. You will also notice that the first 2 sizes of traditional wood screws generally don't have smooth shanks. That's simply because they're just too small for one. Next is the thread diameter. This is also known as the major diameter. This is the measurement from the outside thread on one side to the outside thread on the other. The last measurement is called the root or minor diameter. This measurement is taken from the point in between each thread. Moving on, the next important thing to know is TPI, or threads per inch. This is similar to teeth per inch on a jigsaw blade, but threads per inch are basically the number of threads per inch of screw length. Lastly, to finish off this section, we need to talk about how the length of the screw is actually measured. But in order to know that, you first must know a few things about the different types of screw heads available. Let's look at 3 of them. The first one here is a standard flathead, and it's characterized by, well, you guessed it, a flat top. And the sides are actually angled at 82 degrees, which allows for the screw to be countersunk. The second one is the pan head. These are the most common of all the rounded top screws, and it's characterized by a broad, rounded top. The last screw combines the previous head styles together, and this one's called an oval head. So why did I show you these 3? Well, because each one of these is actually measured slightly different than the other one. The rule to determine the screw's length is the amount of screw that sits beneath the surface of the wood. For example, this 2.5 or 63 millimeter long flathead is measured from the top of the screw to the tip. Why? Because this screw is designed to be installed flat or flush with the surface. However, the other 2 screws are measured from a different starting point. If we look at them now, both of the screws I have are 1.5 inches or 38 millimeters long. But as you can see, this one here is actually taller. Why is that? Well, it's because for the pan head, the 1.5 inch measurement is taken from the underside of the head. Again, once this screw is installed, the head will remain above the surface of the wood. Now, as far as the oval head, this one will be countersunk up to about the halfway point, leaving the rest of the head above the surface. Why are all these things important to know? Well, it's the foundation to understanding the numbers on the side of a screw box, or a bolt, or machine screws for that matter. And speaking of a machine screw, let's start there for our first example. Marked out on the front of the package is 3 numbers, an 8, a 32, and 1.5 inches. The first number is the screw's diameter, which in this case is the US gauge number 8, which has a shank diameter of 5/32. The second number is the TPI, or threads per inch. Here in the US, for every inch of thread length, there is a certain number of threads. And for this screw, that is 32 threads. The last number is the length of the screw. And as we already covered, that measurement is taken from where the head sits flat to the surface to the tip. Because metric is used so much as well, let's quickly look at a metric machine screw. This time, instead of having the gauge number like a number 8, we have a diameter size noted as an M6, which is a 6 millimeter diameter screw. The second number is not threads per inch, but rather a measurement between the threads, or millimeters per thread. And the last number is the length, and in this case, that's 25 millimeters. So now that we looked at the numbers on a machine screw, let's go ahead and look at the numbers on a wood screw. Here on the front of the package, you can see that there are only 2 numbers this time. the gauge, and the length. In this case, if the TPI is not listed, you can assume that the screw has the standard number of threads. And for a number 10, that is 13 threads per inch. Up to this point, we covered almost everything except for the different types of drive options. Here in the US, there are 3 types of drives most commonly used, and the first one is a Phillips drive, the next is a square drive, and the last is a Torx, or better known as a star drive. Phillips is still widely used, and for the most part they work great, just as long as you use the right size bit for the screw. Now when you're looking for a more positive connection, the star drive does provide that, with very little chance of stripping the screw under high force. And of course, last but not least is the square drive, as this too provides a great connection between the driver and the screw. Bottom line, if you're going to be installing a lot of screws, like say for a deck or a bigger construction project, choosing a bit or a driver that has a really secure positive connection is going to be the way to go. And I think in that case, it's got to be the star drive. Moving on, let's quickly talk about pre-drilling and correct screw depth. First, screws hold securely because of the threads, not because of the shank. Therefore, what pre-drilling does is removes the thickness of the shank material so that the threads can grab the wood for a very strong connection. Now I won't get into the specifics about how to pre-drill because I've already done a video on that, and I'll leave a link up here and down in the notes section. Second, as a general rule of thumb, whenever you're screwing 2 pieces together, the screw should enter at least halfway through the thickness of the material you're screwing into. For example, if you're screwing 2 pieces of 3/4 inch or 19mm flat stock together, you want to choose a screw length that will drive at least halfway through the bottom. So in this case, the closest screw length would be 1.25 inches or 31mm. Before we end for the day, let's look at the available sizes for the 6 most common traditional wood screws. We'll check out some of their uses, and then we'll cover a few of the non-traditional screws just for fun. Out of all the available screw sizes, the most common are the number 4, 6, 8, 10, 12, and 14. The number 4 is used for very light projects, like installing small hinges or on boxes or other smaller woodworking projects. They are available from 3/8 of an inch to 1.25 inches. The number 6 would be used for things like larger hinges, drawer slides, and other woodworking projects. Their available sizes are 1/2 inch to 1.5 inches. The number 8 is the most common size used, and it's a great general purpose screw. The number 8 is available from 1/2 inch to 3 inch. The number 10 is used on a lot of outdoor projects like decks, porches, and that's just to name a few. They are sized from 3/4 of an inch to 4 inches. And lastly, the number 12 and 14 are used for heavy duty construction when size does matter. These are available from 3/4 of an inch to 4 inches as well. As far as the non-traditional screws, there are a ton out there, so let's quickly look at 7 of them. The first one is a bugle head, which is very similar to the flathead, but as you can see, the head is shaped more like a bugle. These are primarily used for drywall and deck screws. The next screw here is the same gauge and length as the one I just showed you, but this time this one has a square drive and the head is much smaller. This is a great example of how the same gauge and length screw can have a smaller head diameter, which makes the screw less noticeable once installed. The third screw is called a trim head screw, and they are characterized by a small diameter head. Both of them are great to be used as a finished screw, meaning that once the screw is installed, you'll actually be able to see it in the end product. The other thing to point out about the screw compared to the last one is the tip here, where you can see that some of the material has actually been removed. What this does is it helps the screw to act as a drill bit, cutting material as it's being driven through the wood. The option is available on many other types of screws as well. Next, we have a modified truss head, which is basically a truss head with a flat washer attached. This type of screw has a few uses, but in woodworking it works extremely well at attaching drawer fronts. Why? Because it has a very big head, which means that it can hold some pressure, but at the same time it has a flat enough profile that it's not offensive. The next screw is known as a pocket hole or a Kreg screw. These look very similar to a modified truss head, but are used along with a Kreg jig system. The last screw is a premium exterior screw. This is a stainless steel screw that has some really crazy threads to help reduce splitting, among other things. This bit is fitted with a star drive, which is arguably the best drive that you could have. Why? Because it creates such a positive connection that you have a very little chance of that screw stripping out. Also, if you look at the underside of the head, you can see what are called nibs. These are added pieces of material that help countersink the screw. To better help you understand today's information and so that you can access or reference that information later on, I've made you a few free downloadable charts. The first chart here looks at the 6 most commonly used wood screw sizes. It shows things like countersink size, shank diameter, threads per inch, pilot hole sizes, as well as the size of the drivers needed for each screw. At the bottom of the page, you can see another chart that shows the metric equivalent to the US gauge, as well as the pilot hole sizes. The next chart will help you to convert millimeters per thread, which is used in the metric system, to threads per inch, which is used in the imperial system. And the last chart I have for you helps with all conversions, from fraction to decimal to metric. All of these charts are available for free on our website. Just use the links down in the notes section below. Thank you so much for watching as always, and I hope you were able to pick something up new today. Thanks for watching. See you in the next one.